Hi everyone, wishing you a fabulous day. In today's tutorial, we'll dive into the world of data integration using Ballerina CData Connector. We'll explore what CData is, what is Ballerina CData Connector, and setting up of Ballerina CData Connector, and we'll walk through a practical example of fetching data from Salesforce. So let's get started. CData offers drivers and connectors for various platforms, allowing you to connect to your data using standard SQL queries. This makes it incredibly versatile for developers and businesses looking to leverage their data efficiently. So, why is CData important? It simplifies data integration by providing a unified API accessing data from different sources. Whether you are building an application, automating process, or performing data analysis, CData helps you to get to your data quickly and easily. The CData Connect Ballerina connector allows you to programmatically access all of the CData Connect applications, databases, APIs, services via the Java Database Connectivity API. It provides operations to execute a wide range of standard DDL commands, SQL commands, and SQL functions for querying data sources. Before starting, make sure you have installed Ballerina. You can install Ballerina from Ballerina's GitHub repo. You can see all the links in the description. And you have to set up a CData account. To use CData connectors, you will need a CData account. Supported data sources, ensure you have access to the SaaS or database platforms you will be working with. As an example, I have taken Salesforce here. In addition, you need to pre-set up Java. I use Java JDK 17, and also you need to set up a compatible Gradle to your Java. I use Gradle 7.3 version. To start, you will need a Salesforce account. You can create one directly on the Salesforce website. Since I already have an account, I'll simply log in. Next, log into your CData Connect account and navigate to the Connections tab. Click Add Connection and search for Salesforce. Begin by visiting the Permissions tab to set the appropriate permissions. I'll enable permissions for all CRUD operations. Initially, the connection status will display as unauthenticated. Provide a name for the connection such as Salesforce 1, then select an authentication scheme. I'll use basic authentication. Make sure to enter the username and password from your Salesforce account. For the security token, go to your Salesforce profile settings and locate the security token configuration. From there, generate a token and enter it in the security token field. After entering all credentials, click Save and Test. If successful, you will see the status change from unauthenticated to authenticated. If not, double check your credentials as any errors will prevent authentication. Once authenticated, go to the settings page to generate an access token. This token will serve as the password in Ballerina CData Connector configurations. Next, create a directory. After that, go to Ballerina CData Connector GitHub page. Fork the repo and clone the connector. You may need to add your GitHub username and an access token generated with repo scope. I enter that credential like this. There are a few configs you need to change. That is this configurable string user string and configurable string password. You can enter your CData access token we previously generated here. After that, we can build the library. To build the library, we can use a Gradle clean build. There is a batch execute.bal file here. It automatically executes with the build. So let's jump into the code. So here's what we are working with. First, we import a few key modules at the top. Ballerina IO for handling input and output, Ballerina SQL for managing SQL queries, and CData modules to connect with Salesforce data using CData Connector. Next, we configure Salesforce connection with a user and a password. With the user and password setup, we create our CData's client instance using these credentials. This client is the bridge between our Ballerina code and Salesforce, enabling us to query the data. In our main function, we are creating a batch of records to insert into Salesforce. The records are stored in an array of maps, with each map holding first name, last name, and company data for each contact. Using a parameterized query array, we are building a list of insert queries for each record. For each data item in insert records, a query is created to insert that record into the lead table in Salesforce. Here, insert queries will contain a separate insert statement for each record. Ballerina's query syntax lets us plug in data fields directly into the SQL query, which is super efficient for creating multiple queries. Now we execute these insert queries in one batch using batch execute. This sends all queries to Salesforce using a single call. The check keyword here ensures that any errors during execution are caught. This function call will insert all records into Salesforce at once. If we log into our Salesforce account, we can see that a lead in Salesforce has been created with a few lead IDs. In Salesforce, lead ID is a unique identifier assigned to a lead record. A lead in Salesforce represents a potential sales contact or prospect who has shown interest in a company's product or service. Salesforce assigns each lead a unique lead ID when the lead ID is created, allowing the system and users to retrieve, reference, and manage each lead individually. The lead ID in Salesforce is typically structured as 15 or 18 character alphanumeric string. If you are working with Salesforce data through an integration like CData Connector, you will need the lead ID to reference the correct record for operations like updating, converting, or querying specific details. Click on the name of a lead. The URL in your browser's address will contain the lead ID. Now let's write some code to connect to Salesforce and fetch the latest leads. This setup lets us quickly access Salesforce data directly from Ballerina, making it ideal for developers who want to streamline their Salesforce integrations. Let's create a new file named retrieval.bal. We start by importing the necessary Ballerina and CData libraries. The IO library allows us to print output SQL manages, SQL queries, and CData and driver imports bring in CData Salesforce connector, which connects our code to Salesforce. Next, let's set up our Salesforce credentials. We define the username and password as configurable variables so they can be set externally and kept secure. We initialize the CData client by passing in the user and password. The check keyword ensures that any connection issues will throw an error, keeping our code safe. We initialize the CData client by passing in the user and password. The check keyword ensures that any connection issues will throw an error, keeping our code safe. Now that we are connected, let's write our SQL query to fetch the latest leads from Salesforce. We use the select statement to retrieve the ID, first name, last name, company, and create a date of each lead, ordering them by created date to get the newest entries first. We execute our SQL query using the query method, which returns a result stream. This stream contains the results we requested. To print each lead, we loop through a result stream. For each record in the stream, we print the lead details and set the has leads flag to true. Finally, if no leads were found, we print a message letting us know. This is useful for situations where the query might return an empty result. Ballerina automatically closes the stream, so we don't need to worry about freeing up resources manually. This feature makes working with streams in Ballerina quite convenient. And that's it. In just a few lines, we connected to Salesforce, fetched the latest lead data, and printed it out. Using Ballerina and the CData connector, you can automate and simplify Salesforce interactions like this. You can find this code and other similar examples at my Medium article. Likewise, you can play with data using this connector. You can retrieve various Salesforce objects like leads, contacts, and accounts and apply business logic to analyze them. You can run complex queries. You can use SQL-like queries to retrieve filtered data, join tables, and group of sort records based on specific fields like opportunities by closing data accounts by revenue. You can insert new leads, contacts, and accounts directly into Salesforce to keep your CRM up to date automatically. You can modify existing records such as updating contact information, sales statuses, or custom fields. You can delete outdated or invalid records from Salesforce in bulk. You can use Ballerina CData Connector in data synchronization as well. You can use scheduled functions in Ballerina to periodically fetch updates from Salesforce and sync them to external database or ERP systems. The connector allows you to implement secure auth or custom authentication, ensuring that data access is compliant with organizational security standards. With batch processing and efficient data management, the connector is ideal for both high volume and low latency scenarios, accommodating both small and enterprise level data operations. You can get more information about this connector at Ballerina Central and Ballerina GitHub repository. Thanks for watching this tutorial.